In this problem, I'm going to teach you some new Excel skills that should be helpful for you moving forward. We begin by reading the data in Q7, which I have copied here for you, gives the daily sales at a real estate agent in Clearwater Bay, Hong Kong. This is the same data that we've examined in Chapter 9. So there is interest in the underlying mean level of sales and also in a benchmark value of $300,000 of sales per day. So those are our marching orders. Part A reads, imagine it is February 1st. Calculate a 90% confidence interval for the mean sales. Okay, let's do that first. Now, to be able to scroll up and down on this particular file without losing track of the questions or the header row here, you can do a neat little trick called freeze panes. So if you click in the cell where you want to freeze both columns and rows, and you click on View, you can click on Freeze Panes, and notice the line that it put in there and up and down. And so now if I scroll, it doesn't change the fact that I still see my header row. So I can scroll down to February 1st, which is right here, and I want to calculate the mean. Okay, the mean of all sales up to and including February 1st. All right, so this is kind of obvious. You say equals average of, from here, shift up arrow, and we go all the way up to January 1st. Oops, something went wrong there. Where is January 1st? January 1st is in B20. Okay, so let me just fix that. Let's try this again. From January 1st, scroll down to January. Okay, so we know it's the B20 to B51. Close parenthesis. That was the range of cells that goes from January 1st to February 1st. Now, I know that I'm going to copy this down. And as I copy it down, I want it each time to begin at B20, but to go down to whatever cell row that I'm on. So I'm going to anchor the B20 with a $sign in front of the 20. All right, that'll give me an average of $300,600 up through and including February 1st. Now watch what happens if I copy this down a few cells and click on one of them at random and put my cursor in the formula bar. You notice that the value begins at B20, but it goes all the way down to B53 now because of the way I set it up. So hit escape. Let's get rid of those for right now. Delete. So we've created a formula that will copy down and move with us. We're going to do the same thing for standard deviation. So equals stdev dot s. This is a sample, so stdev dot sample. Open parenthesis, and I'll select from. You can actually, you can program these things by hand. So you say B:20. No. B20 colon to B52, close parenthesis, and then go back and put a $sign in front of the 20. And we hit enter, and if we check it by clicking there, we see that it does in fact, oops, it wasn't B52, it was B51. Professor Ellis, please. All right, so we've got here B20 to B51. We've got here B20 to B51 with a $sign in front of the 20. Okay, for our standard error, all we need to do is divide the standard deviation by the square root of the sample size. So that will be equal to our standard deviation, which is here, divided by SQRT, square root, open parenthesis. Now, how many have we seen up to here? Well, we're going to have to count them. And there is a formula that counts cells that have numbers in them. You want to know what it's called? Count. Okay, so count, open parenthesis, and we're going to go from B20 to B51, and we're going to put a dollar sign in front of the 20, dollar sign, and then we're going to, let's see, we close the parenthesis for count, we need to close the parenthesis for square root. So we now have the standard deviation divided by the square root of the sample size. Enter. $81.45. Okay, so we've got three good numbers, the mean, the standard deviation, and the standard error on February 1st. Now we need to calculate the lower and upper bounds of a 90% confidence interval. Well, you will recall that the formula for a confidence interval is the mean plus or minus the t-statistic times the standard error. Now, how are we going to calculate a t-statistic for a 90% confidence interval? The t-statistic for a 90% confidence interval, I actually went out and grabbed a graphic off the web so that you'd have a clear picture of how that actually looks. If we want the middle 90% under a standard normal curve, this is what it looks like. So you've left 5% under the left tail and 5% under the right tail. So you have to ask yourself, what is this number right here? How many standard deviations is it from x bar, the mean, up to the boundary of this 90%? The formula that we use to calculate that in Excel is we can use norm.s.inv. So I would put in equals norm.s.inv, and all you have to put in is the probability. Now, don't be tempted to put in 90% here, because you have to understand how the formula thinks, or how the formula was designed. It was designed to calculate the area under the normal curve all the way from negative infinity to your far left up to and including some number. So if we want to find the value of right here that leaves 5% in the right tail, we actually have to put in 0.95, which will include this 5% that's in the left tail, so that we can get that value, and then by symmetry we can use the negative value over here. So if we put in 0.95 and a closed parenthesis and hit enter, we get 1.64, and if we go to the home screen and decrease the symmetry on that so we can get a nice number to work with, we get 1.645, let's call it 1.65, that's what most people do. So that's a 90% confidence interval, 1.65. So that's what we needed to know to calculate the lower and upper values. So we would say the lower value is going to be equal to the mean plus or minus. Actually, we're doing the lower value, so we're going to do minus. So lower is the mean minus 1.65 times the standard error, which is right there. And we hit enter, and we get 166.2. The upper value is equal to the mean plus, not minus, the 1.65 times the standard error, boom, and we hit enter. So the lower and upper limits of a 90% confidence interval on February the 1st for the sales is 166,000 up to 435. What is the T statistic? Produce a confidence interval for each remaining day of the year. Okay, let's look at the T statistic for this mean sales over here. We know that that is equal to, T statistic is going to be equal to the mean minus the benchmark value divided by the standard error. So that will be equal to the x bar minus the benchmark of 300, which we were given in the problem. And let's put that in parentheses so that the order of operations isn't compromised. And divide that by the standard error, which is right here. And so we get a T statistic of 0.008, which is quite low. All right, the nice thing is the way we've set up this formula right now, the formulas in all these 1, 2, 3, 4, 5, 6 cells, is that we have designed them so that they can be copied down without changing what they do. So let's now select all of them and drag them down all the way through December the 30th. I know there are easier ways, but this is just one way of doing it. So we're going to let it go there and let everything copy down. And now we have everything we need to be able to answer the questions. We've produced 90% confidence intervals for each remaining day of the year. And we have tested whether or not the mean sales differ from $300,000 per year using a T statistic. Part B says, imagine it's February 1st. Test whether the mean sales differ from $300,000 per day. Well, repeat this for each remaining day of the year. At what point is it clear that mean sales deviate from the benchmark? Okay, I'm going to do something real quick here. I'm going to take a Shift Command and select all of those T cells and insert a line graph just so you can see what it looks like. And we can see what's happened to sales here. Well, let's put it over here on top of that. So we can tell that there were times when we had high values for T. And if our null hypothesis is that we are above 300,000, there are instances where we have high values that suggest that we are well above the standard. I think the highest is going to be somewhere in March here, February, March. We get up to any positive numbers there. Okay, here we got some positive numbers. And we get all the way up to .2, .3, .377. Those are pretty high. 3.77 standard errors above the mean. Yeah, that's highly unlikely that it's not true. So, but then the numbers start to go negative. And all these negative T values are going to suggest that we are well below the expectation of $300,000 per day. So we have deviated from the benchmark. And that's how you do that one.